In this video, we'll be taking all the models that we've previously modeled in the last video, and then we're going to take that into Maya Arnold and we'll render it with Arnold, and we will take a look at how we can set up both an area light, that's going to be this main light over the top. We're going to take a look at how we can do bounce or fill light using a SKYDOME. And then we're also going to take a look at the AI standard surface material and how we can use that to drive the look and the appearance of things. We're going to learn how to put a little bit of volumetric fog within the world, so you can kind of see that right in through here. And we're also going to be able to take a look at adding a depth of field effect, so that kind of blurs out things over here, and we've got this area in focus. Then we'll take a look at the material type and how we can push that to where we can do some different materials and get some different looks out of here. So let's go ahead and get started. Okay, here we are on the scene for the modeling that we were in the previous video. And if you remember, we set up our real-time lights that we have, and that's a pretty cool setup for just viewing in the viewport 2.0. But now we're going to start building some Arnold lights. So what I'm going to do is change it from the modeling subset, and we're going to put it onto the rendering subset like this. And then we're going to go to Arnold, and we're going to go to lights, and then we're going to go create this SKYDOME light that you see here like this. I'm going to go ahead and take the real-time light folder and hide it, and that's Control H to hide that. And if you remember, we've got display and you got show and hide within there, and those are the hotkeys for that. You can do Control H or Shift H to hide and show. So we're going to start our new Arnold light setup. So let's grab this AI SKYDOME light that we've just made and hit Control G, and that will group things, or we can go to Edit and then Group like that. And let's name this Arnold Lights like this, and let's middle mouse drag this up into the lights area like this. Okay, if I go to panels, perspective, you can see with this SKYDOME light, it doesn't quite go outside of the bounds of our infinity wall, and that's fine. It's not a big deal. If you want to scale it up though, you can tap R, or you can put it on the scale tool over here, and you can just scale this up to where it's larger than the SKYDOME. This is just going to be used for lighting our scene, so it doesn't really matter exactly the scale for it. I'll just put it at 2.5 like this, and I'll go back to this panels, perspective, render camera, and then let's go ahead and go to Arnold and then open up the Arnold render view that you see here. And the size of this is going to be determined by what we set within here. If we go to the Common tab, I set up a resolution of 2560 by 1440, and that's the resolution of my screen that I'm working at. So if we render full res, it will basically fill the entire screen up. Now, it's going to take a lot longer to render a larger image like that, so we don't necessarily need to render a really large image like that. So we can go to View and go to Test Resolution and then bump that down to 50%. And now I'm going to hit the play icon that you see here, and you can see this is going to be the first thing that we get to see whenever we render with this. All right. And while it's doing that, I'm just going to pull this thing down and then try to resize this window just a little bit to get it to fit within here just a little bit better. So you can see right now, as it renders, you've got these tiles or buckets that are starting to render. And I'll show you after I get this resized here. If you go to Window, make sure you got this Show Render Tiles on, and it'll show you currently the stage that it's at for rendering. Now you might be wondering, if this is the first time you've ever dealt with ray tracing, what is going on here. Well, basically you can see the image is rather noisy at the very beginning, and then it keeps refining it over time. That's because with ray tracing, it takes a ray or a calculation from the camera and then hits a surface, and then it does a certain amount of bounces depending on if it's transparent or not and things like that. But basically it does maybe a rough pass first, and then it keeps refining that over time. There's a lot of information out there about ray tracing and trying to understand exactly what's going on there. That's probably a really long video all in itself. So if you want to know about ray tracing, you're probably going to have to do a little bit of digging and try to understand exactly what's going on there. But the way I just view it is it's a pretty intensive math calculation that's going on to simulate real world lighting. And the results are awesome, but it does take quite a bit of time to render this stuff. So that's what I think is kind of interesting now. We've got real-time ray tracing and global illumination happening in game engines like the Unreal Engine 5, and those techniques are getting better and better. And that is happening in real time, but the quality is just not anywhere close to what we have inside of Maya or something like an offline render like Arnold. Okay, so currently this is where we sit with things. Let's go ahead and open up the Arnold lights, hit this and hit Control A to bring up the attribute editor, and that's sent under Windows, General Editors, Attribute Editor if you ever want to pull that up. And you can see our intensity is set to 1 right now. But the color is just being driven by this this thing that you see here. So we could change that to like a red, and you can see it's going to re-render. What we really want to be rendering with is a high dynamic range image. So that's an image that has a big exposure that goes up and down and has a big range for that. And if you capture real world lighting with a camera, you can light your scenes with that. So let's go ahead and do that. So under color, we've got this little checker icon, and let's go ahead and click that, and that's going to allow us to open up a lot of different nodes that we can grab, but we just want to go to this this file node that you see right here. So go ahead and click on that, and as soon as we do that, it's going to change because we don't have an image in here just quite yet. I'm going to name this HDRI and then call it TEX like that, and we'll go ahead and navigate and find where our images sit for this. So over time, I've been collecting a lot of different HDRI files that I've found online, and you should be able to find a lot of free files online as well. One thing that I am using lately is the HDRI files from Substance Painter. So if you install that program, you should be able to dig through their directory and find the HDRI files that ship with that program. And so I've grabbed those, and they've got these 3 different environments. They've got exterior environments, interior, and studio, and I'll give you some examples of what that looks like. So if we do an exterior, their default is this panorama.hdr, and if I open that, you can see the image change in the back here pretty quickly, right? So it takes that whole environment and it maps it to that sphere that we had, and then it reflects in or grabs this and treats this as lighting information. So you can see all the primitive shapes that we have now are starting to reflect that environment, and it's kind of blurry on here. That's just because of the settings that we have for the material, but you can see over here we're starting to reflect that environment that you see within here. One thing I want to do is make sure our SKYDOME, I'm going to go ahead and go to our infinity wall and hit Control A for that, and then I'm going to go to render stats and tell that to not cast shadows. You can see that's a huge difference because that SKYDOME is sitting outside of the infinity wall, and it's acting as if it's a big wall, and it's these things are inside of there, so it's casting shadows on there. So I don't want that to happen, so I just turn that off, and you can see what a big lighting difference that was just doing that alone. So I'm going to click back over to this AiStandard light, and we can play around with the intensity. One thing that I do want to kind of point out is if we let this image resolve and finish up, then we've got a certain amount of noise in the image. Now we'll talk about samples and upping samples. When we do that, it increases the render time. So one of the things that I've kind of learned taking a look at some of this information is that we can start to up the samples of our lights, and that will help a little bit. So within this render view, you have the ability to store a snapshot. So if we click that, we can store this as a snapshot, and we can pull that tray up and down using this. So we've just stored that image. Let's take the samples and let's just put this on 3, like this and let it render and finish rendering. Okay, so I paused the video and let that run. You can see in the bottom left hand corner here it tells you how long it actually took to render something, so that was 58 seconds for that. Let's go ahead and store a snapshot for that as well, and let's open this tray up. So now we've got two snapshots, and if we hold down Alt and click and drag, we can move this around. If we middle mouse drag, we can zoom in and out. So you can see there's a certain amount of noise in the image. So this is how much noise that we had before. That was set to samples of 1, and then if we do samples of 3, you can see how much less noise that we have in the image. So that's moving in a good direction. So I'll go ahead and leave the samples on that for 3, and I'll go here and I'll click off this little eyeball icon so it says clear snapshot display, and that puts us back in the mode of rendering. So I can tap F to frame this back up. The next thing is I don't want this to be a light that's casting shadows. I'm going to turn this off, because what I'm going to end up doing is just using this SKYDOME light to simulate extra bounce light to just kind of light up the whole entire scene. So I'll actually take this intensity and put it at like 0.2, somewhere in that vicinity. So it's going to get quite a bit darker at that point, and that's okay. And the next thing that I'm going to do is I'm going to actually assign an Arnold specific material to all these pieces that we have here. So I'm going to go ahead and stop the render for just a second. I'll pull this down here so we can see what's going on. So I'm going to select all the primitives. I'm going to select this, hold down Shift, select the torus, and I'll hold down Control to add an additional selection of the infinity wall outside of there. So to assign a material to this, it's pretty easy. We can just go ahead and right click over our objects and then go to assign existing material. I'm sorry, we're going to go create a new material. So we'll assign a new material. And so let's go ahead and go to the Arnold area and click on this, and you can see there's an AiStandard surface. So that's the one that we're going to use. Go ahead and click on that, and it should actually assign all those different objects that material that you see there. Now at that point, now that it's created, we can go to the assign existing materials, and you can see if we have to assign anything to that material, we have that as a possibility for us. Okay, so right off the bat, let's just do another render on this, and you can see how that changes things quite a bit. Now do remember, we've got the infinity wall and all of our pieces are sharing the same exact material. So if we change any kind of values, it's a little bit lighter. I want to make this like a mid gray, so I'm going to go ahead and click on this, and it's set to 0.8 right now. Let's do 0.5 and get it to a mid gray value like this. The other thing that we can do is if we take this metalness, it's either going to be, you can do an increment of it if you like, but everything I've learned about materials is something is supposed to be non-metallic or it's metallic. So we're just going to drag this all the way up to metalness all the way to 1 on here like that. Now you can see it does increase the contrast quite a bit on this. So we were at 50% gray. If you want that to be a little bit lighter, you could go back to the 0.8 if you like, and you can see that is going to give that kind of look for the metal. You can tint it towards a color if you like, but just for showing off models and things like that, I just like a nice gray kind of color. So this roughness, if we drag this roughness to the far left, we're going to get basically chrome at that point. And I think you saw that the default value is something like 0.2. I tend to like this metal kind of look where the reflections become kind of blurry. So if you think about roughness, if it's got no roughness on the surface at all, it's super polished and super smooth, right? And so that's why it's super reflective. And as it gets more rough, going to a value of 1, if a surface is more rough, it becomes more matte and it doesn't reflect light quite as much. So that's why it starts to look something like this. And maybe this is like one of your painted walls that you might see around you. And so this is like 0.75, and if you drag it all the way up and there's no roughness at all, it's a completely and totally matte looking surface. So if we do something like let's try 0.35, somewhere in that vicinity, so we're still getting some nice reflections that are going on here, but it's still is blurry enough to where it's kind of hard to make out these shapes and exactly what it is that it's reflecting. I tend to kind of gravitate towards this a little bit. A little bit later, we'll look into changing a whole lot more values on here for transmission, which will simulate the surface being transparent. We could take a look at a subsurface, so that's something like skin, and that's how light kind of bounces around underneath the surface and kind of pulls back out of the surface, and it has an effect like that, or like a certain type of rubbers and things like that. And there's also a clear coat that you have on there. Emission will make this thing have the appearance that it's self-illuminating, and within this type of render, it actually kicks off light data. So it's actually got some light properties to this on here, so that becomes kind of interesting as well. So I'll just take the weight on that down and I'll just put this at black like that. Okay, so this is the AiStandard surface. It's got a lot to it. There's a lot that you can do with this material, so it's very versatile, and it's going to take quite a bit to kind of really learn the ins and outs of that, but we're just going to keep looking at it as a kind of a simple setup. Now you can tell with this this material that we put on, there's quite a bit of noise that's been introduced into the image. That's because of the amount of specularity that we have and the amount of reflectivity that we have going on, because you saw from our snapshots before, we had a pretty good looking image with not a whole lot of noise. So we're going to get into this, fixing this up with the samples and everything in a little bit, but before we do that, let's add another light type in here to our scene. So I'm just going to drag this down. I'm going to go to Panels, Perspective, just so we can see what's going on with this. And we see here. And then I'm going to go to Arnold, and let's go to Lights, and let's do an area light this time. Now with the area light, I know this is starting to render, so let me just stop this so we get better performance going on. Drag this back down. So we've got our area light. Let's go ahead and middle mouse drag that into our Arnold Lights area. And I'm going to put it on the Move tool, tap W for that, and then I'm going to move this light out like this. It's going to be hard to see the actual icon for this, so let's go to the area light and let's put this at 10 like this, and now I can kind of see what's going on. I want to put this at an angle, so I'm going to tap E for my rotate tool, and don't forget you have access to move, rotate, and scale over here in this area. So I'm just going to rotate this, and maybe I'll do 45 degrees like this, and maybe I will rotate it just this way a little bit, like this. Sorry, I'm going to put this on world instead of object, and then that way I can just rotate it just like this. And I'm going to move the light, and I'm going to push the light. Let's put that in world as well, so I can just move it over this direction here. So if we're moving in world space, then it's just going to be along this axis that you see here for Y, X, or Z. So that comes in handy sometimes, and sometimes you want to be moving and rotating an object, which actually takes into account the object space. And see, you can see the orientation of that changes a little bit as we do that. Okay, so the intensity. I'm going to pull this back up, and we're going to start letting this render again, and I'm going to show you what we have. There's probably not going to be much of a change on here until we start to really up the exposure. To make this more obvious what's going on, I'm going to reduce the SKYDOME light. So let's put that at 0.1 like that, and so you can see that's how much we got for our bounce light. We'll go to the area light here, and I'm going to take this exposure, because if I don't, I'm probably going to need a really high value, like even 8,000. If I do 80,000, that's not doing too much. And then if we got 800, so that's a pretty big value to work with, right? So if I put that back down to 1, we're not going to get a whole lot, but we can play with this exposure. And exposure, to me, it feels like exponentially raising these values really high. So if we went to something like 15, we're still not getting tons. If we go to 18, starts to brighten up quite a bit more. Let's go to 20, and that's really getting some brightness on there for us. Let's go even higher to 22 or so. So what I tend to like to do is to overdo the light just a little bit like this, and then now we've got a control with this intensity where we can drop this down and do like 0.8 or 0.7, maybe go down to 0.5. So maybe this exposure still feels a little bit too high to me, so maybe I'll go to 20, and then let's go to 1 and through there. Maybe I'll do 21. So then I got some way to kind of push that down a little bit lower like this. Because if I do it at 22 and I drop this all the way down to, let's say 0.2, I think that feels pretty good. So I don't know. I'll leave it up to you what you want to do with the values on there. But I want to get it somewhere in this ballpark right around here like this. Okay. So now we've introduced a new light, and we've got a whole new round of samples to kind of contend with on this. So I am just going to raise up the samples on this light already before we start off. So then that way we kind of know we're doing everything that we can to take care of the samples on that light already. And the other thing I can tell you about upping the lighting samples that does help is the shadow quality that we end up getting from this. I'm going to take this AiSkydome light and I'm going to put this at 0.05. I just want to see like how much light we're actually getting from just like the area light alone. So maybe do 0.075, just raise that up a bit, and then this area light, I'm going to raise this up the intensity to 0.4, maybe 0.3. Somewhere in that vicinity. So let's take a look at what happens with this light if we make it a lot smaller. So I'll just take this area light, I'm going to hide this right here, and let's make this a scale of 1. So not a whole lot changes with what is going on with the light and how the light looks. But again, if you start to take a look at the shadows, if we make that light really small, you see how the shadows are nice and crisp on there? So if you want nice crisp shadows, you're going to use a smaller value for that, and take a look at how the shadows are falling on here. Now if we go back to something like 30, we get really blurred out kind of shadows. They're a bit blobbier. So depending on what you're going for and what the look is that you're going for, that kind of matters for the scale of this. I tend to like this look of softer shadows. So if I do something like 20, I'm still getting the shape of the shadow, still nice and soft for everything. But I do think with the softness of the shadow, you're going to have to contend a little bit with the noise that's happening on there, like that. Okay. So obviously, depending on where you place that light matters for the direction of the shadow and everything else that we've got going on here. I have noticed that when we take a look in the viewport, that sometimes this can be kind of hard to work with, because what happens in the viewport doesn't really start to match too well over here. So I don't know how helpful it is for this lighting information. If we tap 5 in here, you can see that the material kind of goes dark like this, and if that ever happens, you can go to shading and you can say use default material within here, and then that way you can kind of just see this default material and everything, and it doesn't affect everything quite as bad. So you can still work with that default material with lighting if you tap 7. So if we tap 5, we can see it this way. So it might be easier for you to work like this in this capacity. So I didn't talk too much about the SKYDOME light, and that the fact that if we change out that image that you see in there, it's going to have a pretty big effect on the way everything kind of looks. So if we go back to this, all this stuff is always live, so we can always go back and change these images. So I'm going to go click on the image, and then I'm going to go this time and find an interior environment, and we've got this bus garage. I'll try that one. And this one's kind of got more orange and yellows in it, so that you can see how drastic of a change that is and how much light might pull in depending on how that light was shot within there. So I think that's a pretty cool look, but again, it is changing things up quite a bit. If we want to use something, if you find an HDRI file that looks more like this. It's under Studio. They've got a series of black and white images, and if we take a look at this one, you can see it's got the light shapes up above. It's dark up above except for these really bright light spots, and then it's got a nice gradient at the bottom. So I think this is a really nice one to render with. And again, if you found that exact image, then you could get the same exact look that I've got going on, but you could go and take a look out on the web to find some images that are very similar to that. Okay, all right, what I'd like to talk to you about now is sample rates for this. So samples will allow us to remove as much as we can from the noise from the image. And so if we go to this area here and load up the render settings, and I'm going to push this over just a little bit and push this over a little bit, and we go to the Arnold renderer tab right here, you can see here's our various samples that we have. And the default is for camera is set to 3, and diffuse to, specular set to 2, and transmission to, SSS set to 2, and volume direct set to 2. If we take a look at this document from Autodesk, they've got some examples of how you can remove the noise and talking about what the noise actually looks like. So here they've got an image where everything's set to the samples here, camera AA set to 1, basically 1 through everything and through there, and even for the lights the samples are set to 1 as well. And you can see how noisy this image is. On this material, if we hover over here, you can see the image is resolved. And basically, if you go through this document, they've raised the samples in each one of these cases to 10 to get rid of everything. So this has got motion blur noise in through here. This has got subsurface scattering in through this material, so it kind of feels a little bit like marble. This is transmission noise, so it's got translucency on there. They're pointing out the shadow noise on here. Indirect specular noise, direct specular noise, and this indirect diffuse noise on through here. So each one of those can be set independently, and basically what they're suggesting is to find out in your image which parts actually need to be resolved to remove the noise that are on there. So the other thing they talk about is rendering out AOVs for this. So AOVs are a way of kind of separating out these different passes, so you could find out what's going on with just the direct, or sorry, the direct diffuse, or the direct specular. Get the specular indirect, the SSS, and the transmission. So you can see this image is all put together, but when you render out these different channels, the only thing you see on this one is SSS, or this one is transmission, right? So motion blur's got its own problems for resolving the noise on there. One thing that we're going to look at in just a little bit is taking a look at depth of field and setting that up, and you can see it takes a pretty high sample count to resolve the depth of field noise that's on there, and you can see they've upped that to samples of 10 within there. Same thing for motion blur. And the diffuse noise, I don't think you'd probably have to go all the way up to 10. Now this video is going to get compressed down a little bit, so it might not be quite as easy to see some of this noise, but there's still, even with 10 samples, there's still a little bit of noise in this image here. Same thing for the specular noise. I think this one's a little bit easier to see, the transmission noise. So it doesn't feel like it's ever quite perfect, but you can remove as much noise from the image as possible. Also, we're going to look at adding some atmospheric depth to our scene, and you can see here's a sample. This is all samples, and then the atmospheric volume samples set to 10 on there, so that'll help resolve some of that. And yeah, so here you can see some of the different examples that they've got here on this one for no depth of field. And if you have depth of field on your image, you can see some of the sample settings that they put on here. So the diffuse samples is pretty low, and so is specular. Transmission samples for SSS3 light samples are set to 3. So these are pretty low, but the camera samples are up pretty high. Here's something else that they show too about noise in these different areas. If you've got noise in your alpha channel, or your indirect diffuse, or direct specular, direct diffuse. So they're telling you where should you go to up the light samples for that. If we go to, there was one area on here on that was just talking about resolving for lights, and it was just basically saying that in the lights you could probably resolve most things in the lights by going a sample of 3 or 4, and we already raised our lights, the SKYDOME light and the area light, to samples of 3 within there. Okay, so knowing that, I was going to show you how we can go and set up the AOVs on here so you can see those and what that looks like. So if you go over to this area, you can find the AOVs that you're looking for, and you could push it over into this area. So we've got diffuse, and if we just push that over, there was diffuse direct, and you could probably push diffuse. There's specular right here. There's specular direct and indirect. You could do the SSS for subsurface scattering, transmission like this, and I think volume direct like this. And if we go back over here, sorry, it was meant volume indirect. So that'll let me push this, and I can push this back over here. Okay, and so we can go and say view, and we've got enable AOVs. We can go to AOV, and you can see this is the beauty pass, and then you can see diffuse direct. Now this is not going to render anything, and this was confusing me for the longest time until I kind of figured this out. If we select this and select our material on this cube, let's go to our AiStandard surface. I put the metalness all the way to 1, and if I do that, there is no diffuse. It's all being pushed into the specular. So if we go and say specular direct, or we go to specular indirect like this, this is where a lot of the noise is happening. That is where most of this metalness is actually being rendered at. So it's kind of interesting if we select one of these objects again, and then we take a look at this metalness, and we just lower it just even a little bit past this 100%. If we go to the diffuse direct, you can see it's going to start to render that out for us, and we'll start to see that as a channel for something that we can kind of work on. Now the noise on this actually looks pretty decent already, like it's being cleaned up fairly well. I just wanted to point out that that was the thing that was kind of happening. So if you use a material and you don't have it at full metalness like that, then you might have to go take a look at those channels and then resolve those. So I'm going to put this on the specular indirect, and let's go ahead and up the specular up to, let's just see what 4 looks like. Now the other thing that we can do, instead of rendering the entire image, is we can do this cropped region. So we can put it on this tool, drag it out on this area, and it's just going to render just that particular area, and it's going to render it quite a bit faster for us. So you can see that after it resolves, it's looking quite a bit better than what it was looking before. We could just keep upping this number and trying to find the sweet spot. If you just bump up really high numbers really quick, then you might kind of overshoot this just a little bit. Something else to kind of consider for this, I know from what I understand, it's better for render times to raise these numbers independently of the camera AA. If you have to raise that, it's basically like raising all these numbers underneath of it. So that's just something to keep in mind, and then your render times increase quite a bit. But this one was tied to depth of field and some other channels that you could take a look through that doc. So there's times that you have no choice but to raise this up if you want to get rid of some of the noise that's in there. So I'm going to try to raise this up to 6 and see how that looks, and let that resolve. Now in their document they were pushing everything all the way to samples of 10. I'm going to go ahead and push that up to 8 and jump up a little bit higher. And again, I think this material type is going to be a little bit difficult to resolve and not have any kind of noise that's happening on it. And I think you have to find kind of an acceptable level for this. So if we go back to the beauty pass, we can kind of see what is happening now at that point with this. We could also take our lights and take the samples of our lights, and again the suggestion said that most light information should be resolved with 4 samples. So you can go higher if you wish, but that was the recommendation that was actually written up on that document there. So a combination of that, and if we do need to raise this up just a little bit, maybe try 4 for this and see how much of an improvement that we get on there. Yeah, so also the shadow quality is going to be driven by mainly your light samples that you have within the lights itself. So you can see it's taking quite a bit longer to resolve the image, but it's starting to get to that point where I think it's at a very acceptable level for what we need on here. So I'm going to take it off of this, and it's going to start to render the entire image, and I'll pause it real quick and come back and we'll see how long it takes to render this image. Okay, the render's done, and you can see it took about 6 minutes and 50 seconds on here. I think it's a pretty good acceptable level for this. I do think this is kind of a little bit of a worst case scenario where the whole entire image is basically this highly reflective metal. So there is a lot of noise in here. So I think I might raise this up just a little bit higher on the very final one. The other thing is taking a look at this. If we go to view test resolution, I'm still not even at 100% of this screen resolution. So the noise probably be a little bit more noticeable whenever you render 100%. But I'm going to just say these are pretty decent settings. The only thing I might do is maybe up the specular to about 10 and maybe pump the camera AA up to about 5 and maybe call it. I'm not exactly sure the exact time that it would take to render those settings out, but obviously when we change that, it's going to take just a little bit longer. So I think that's enough to get you started to kind of understand about the samples and how to look into that and work with the AOVs. The only other thing that I didn't really kind of talk about that's a possibility is that you can output these denoising AOVs. And so whenever you render, basically there's a tool with NVIDIA, I think it's called Optrix, and also Arnold has their own tool for taking these noisy images and then going through like a filtering type of process where it does the best that it can to kind of artificially remove the noise from the image. And from what I understand, the NVIDIA one works okay for like still images, but if you have an animation or something like that, you might see some flickering. So if you have that going on, you want to use the Arnold denoiser tool that they have, and it has what's called temporal sampling. So it does sampling over the course of multiple frames. So from what I understand, it just analyzes previous or post frames, and it builds the denoising based off that, so you get a stable image when you're rendering render sequences like that. But I'm not an expert at any of this. I'm just kind of starting to get into some of this. I'm really excited about real-time ray tracing and global illumination that's happening in Unreal Engine 5, and some other engines out there are probably going to follow suit. So this is just the beginning of us starting to get into real-time. I definitely want to have an appreciation for where the ray tracing techniques that are being used in the real-time engines, where they came from, and then see the quality that we have currently with offline. These are considered offline renderers like this that take lots of time to render the frames. I want to have an understanding of the quality level that's achievable with that versus what's going on real time. I don't know in the future how much longer it takes for us to catch up in the real-time world to get to this kind of quality level that we have. I'm just going to take a best guess and say at least 5 to 10, probably more like 10 years down the road. But we'll get into this thing about Unreal Engine 5 having some of these techniques running in real time, and I'm impressed. I think it looks pretty cool, but if you think these images are noisy, then you're definitely going to think the real-time stuff is very noisy. So again, I know it's very early on in just kind of learning some of this stuff, but I think it's good to have an appreciation for where these techniques came from and where they're headed. The other thing is, if you want a really super high quality render, this is the place to do it right now, and I think it's going to be that way for quite some time. So I'm just getting started and try to understand the sampling and the AOVs, and I think as time goes on, you'll at least have some kind of base foundation for building your imagery as well. Okay, now that we know a little bit about lighting setup and how to get our samples going and getting a decent render, I wanted to talk to you a little bit about setting up some different material types. So let's go to the AI standard surface, and so I just selected any one of the objects in here. It's kind of interesting, you can actually select objects within this render view that you see here like this. So I should be able to get to the material that's assigned to this way with the attribute editor open. And if you remember, we can go to Windows, General Editors, Attribute Editor to bring that up. And right now I've got this metalness. From what I understand about metal, you're really not supposed to mix values of this. It's either supposed to be pure metal or not. And so if it's pure metal, you can see it's a value of 1. If it's not metal, we put it at a value of 0 like this. And if I go to render this out, you can see what a difference that we have in the model there. Now, I did raise the value of the color up on when it was in set to metal because it darkens it up quite a bit. So if I want to set mid-gray, I can go back to 0.5 for this, like this. And so you can see the way that it's shading through here like this. If you don't like how dark it gets in certain areas, you can go take your SKYDOME light and you can bump up the intensity of that a little bit. Now this is rendering pretty hot in this area, so it's I am kind of blowing out the image a little bit this way doing it. So maybe I took the area light, and if I pushed it back a little bit, if I went and looked at this through the perspective view and then actually put on the move tool and then try to take a look and see where we're at with this. So it is rendering right now, so let me go ahead and stop that to get better performance. And so I have the light kind of pushed off to the side a little bit. If I wanted a more even render, then I could do something like this. I could go put this here along X, and then maybe at that point then rotate the light here like this. Okay, and so this is going to give us a much more even render across there. The intensity is pretty darn high with this, so if I'm doing this, then I need to kind of readjust this. So again, depending on your materials, you might do a little adjusting with your lighting and stuff like that. So I'm going to put it at 0.15 just like that, and then if I backed off and then pulled this light back a bit more, I can keep that from being so hot. The closer the light is to the objects, it's gonna produce that kind of hot feeling that you see here. So I think this is pretty good for this. So this kind of reminds me a little bit of a blend material that you see here. And on specular, we've got a roughness of 0.35. If we push this down to 0.1, you can see it's going to get a whole lot more reflective. So if you want a little bit more reflectivity in there, you could go ahead and push that up like that. If we change this IOR, index of refraction, I believe is what that stands for. If we put that to 1, it has something to do with the way that this thing reflects the surfaces. So if you see the reflection that we had before, it kind of goes away at that point, and it becomes a bit more matte. I'm trying to think of if this image resolved, if we cropped in on just the sphere or these two objects and let those render, if that starts to push the reflectivity to the outer part or the inner part, and I'm a little bit confused as to remembering exactly which one it does. So if I push this up higher, So we're going to do a higher index like this. It looks to me like this is making it more reflective in the inner part, and as the camera moves away from the object, it becomes a little bit more matte. I think we can go this direction with things too, which if we put that at 0, which becomes interesting, where it becomes like a pure chrome kind of object in here. So interactively, we can kind of see how this thing starts to grow in here. So I think I had that backwards. So as you can see, it's more reflective on the outer part, and then gets in here like this. So see if we crank this up. I'm going to go like a really high number like this, so it starts to really push out. But yeah, I probably need to do a little more investigation to exactly what that number means. I do know, like, if it's translucent, that has something to do with refraction and the way the light kind of bends through the object on that. So while we're talking about that, we've got this set to roughness of 1. So if we put this back at 0.35 and made the surface a bit more rough, maybe I go even 0.45. like this in here, we can get a nice soft highlight on there. I'm going to go even higher, 0.5. And then it is possible with this coat that you can put like a clear coat over the top of it. So you could get almost basically two specular types. So this almost becomes like a layer. And then if you take the weight on this and start to drag it up, you can get a different roughness value over the top of what you had kind of sitting underneath of it. So I believe you can do something like you know, car paint or something like that. So if we took this roughness and drug it all the way down to 0, you can get a super tight highlight on top of that. And if we go a little bit softer with it, start to mix on there. So you'd have to play around with the values and see where you end up, and you can build these different material types based off of what you're doing there with this coat. So I'm going to take this off. I am going to go, let's go to the transmission area and let's crank this up. Now I do have the same material on the infinity wall, and if we're starting to make this thing semi-transparent, it's going to make our infinity wall transparent as well. So I'm just going to select the infinity wall, and I'm going to right click over this and say assign existing material. I'm just going to use the Lambert material on it for right now. So then that way we've got a we have a solid backdrop, and then we can start to see what would happen if we start to play around with the transmission on these things here. Now, from what I understand, you might have to select the actual object and hit Control A to bring up the attribute editor for it. And then if you go to the Arnold area, it's set to be opaque like this. So if you want it to be transparent, I believe, at least from what I understood in the past, you had to select your objects and you had to turn opaque off for the different meshes. So something that I'd like to point out to you is that if you want to get quite a few different preset material types, there are presets that sit within here. So I just went to this thin plastic and hit replace on there. You can actually blend from like whatever your values are to something else that you've got here. So you might want to go through here and take a look at the values that they've set for some of this stuff. So they've got something like jade is in here. It's really cool. That way you can see these different materials that they've got set up, what they've done in each one of these areas, and start to get an understanding of what these values can do for you. The other thing that I wanted to point out is that there is documentation and nice little renders and explanations for what these values do. So if you kind of want to do a little bit more of a dive on some of this and take a look at some of the values to build different material types, you're able to do that as well. And then when you build a material type that you like, it's possible to save a preset. So you can see this is a material type that I've already built and I thought was kind of cool and interesting. And so after you build your material type, you can go to presets, and you can say save that preset, and you can give it a name, and then it shows up down here, and you can use that for future projects. So yeah, so that's basically all I really wanted to show you for the material types. There's obviously a lot that kind of goes into this, and we're just barely scratching the surface. I know I'm just kind of showing you some of these values and sliders and things like that, but really the best way to kind of understand this is to do a little bit of experimentation yourself, and then go through, and like I said, build yourself a little material library. So that can be very helpful if you build a couple different metal types and plastics, things like that, some different glass and things. That way, whenever you go to render in the future, you're able to just kind of pull up those presets and have those at your disposal. So I think that can become a very powerful tool for you. So the next thing I'd like to talk to you about is adding a little bit of atmospheric depth or a little bit of atmospheric haze. And we'll use the settings that we have within here. Let's go to the render settings. And if we go to the Arnold renderer and go to environment, you can see they've got an atmosphere area. And you've got options for this. The one I'm going to have is create AI atmosphere volume. So we'll go ahead and do that. They do have a AI fog as well. And there's also a standard volume. But we're just going to take a look at this AI atmosphere volume. So let's go ahead and click that, and that'll create a node that you can get access to through here. Now you do have to have the attribute editor open and then select this to get to the values. I think this is kind of a little bit of a weird way that, I don't know, it's just kind of difficult to get to at times. So I always had to have that open, and remember, go to Windows, General Editors, Attribute Editor, open that up, and then once you have that, you can click this icon here and you'll get to this. So the density setting, this uses really low value. So if we do something like, let's just do like 0.1 and then see what we get. It's like pure white. So 0.01, still very, very bright for this. We do have attenuation, so if we pull that up, that makes it stronger towards the light source, and it's really coming from this area light and then dissipating out over that. So if you want it really strong at the source and then to kind of fall off, you can use this attenuation. There is a attenuation color. I don't have the best understanding of that really for what that does. There's also the samples within here for this. It's set to 5 for just the volume settings itself. So you might have to pump that up. Again, if we went back to that document that showed how to resolve noise, they gave some settings within there for what to take a look at for just upping the samples for the atmosphere itself. So you can, this is a little bit more straightforward than the anisotropy, this attenuation color, I'm sorry. If you want to make your fog color, like let's say we push it towards a blue or something like that, it's pretty easy to kind of understand how to push these towards a value like this. So I think that can become pretty interesting and pretty neat. So maybe you've got a sunset and you're trying to do that golden hour look through there. That's a possibility for you. So I'm just going to take this and put this back to 0. I'm going to try to get a density 0.0025 somewhere in there, and that's still pretty bright. And put this just at white like this. Let's do 1 for this. That's still pretty bright, so I can do 0.5. And again, for this render, I really don't want too much atmosphere in there. I just wanted to show that that's a possibility to kind of add to this. Now, if we set up our lights and pulled back from this and set some of our shapes underneath the area light, you could, if we set this up correctly, you can get the illusion that that light is traveling through the atmosphere, and you can get some light shafts going on and stuff like that. So it's not super relevant for this render. Just adds just a little bit of lightening to the image and adds just a little bit of depth to the image, but I just wanted to pull it to your attention and show you that this is a possibility for you to have for something to kind of render out. So I'll let that finish up, and we'll take a look at what this looks like when it's done. Okay, the image is done rendering and resolved. This took 10 minutes to render, and I actually took the samples of the camera A and dropped it down a bit to get this to render a little bit faster because it was taking quite a bit of time. So you can see as we start to add things like this, we're just going to add complexity to the scene and up the render time. But I think the results can be pretty darn interesting for this. So the next thing we'll take a look at is depth of field. Okay, so the next thing we're going to be looking at is depth of field. And basically, I'm going to show you a setup to where we can visually get an indicator that kind of says the area where we want to have in focus, and then outside of that area, it goes outside of focus. And then we'll just talk a little bit about the sampling rate that is needed for this. Okay, so let's hop over to Maya. So in Maya, we want to select the camera that we're rendering with. And if we go to the Arnold area for this and open this up, you can see that there is a depth of field. So we'll go ahead and enable depth of field. And then we've got a focus distance. If you kind of know the world units that you're aiming for, you could change this number. Let's just say 500 or something like this. And then the aperture size is set to 0, so you're probably not going to see much like depth of field on this, not much kind of blurring on this. If you want to set that up higher, you can put it at something like 5 or so, and you can see it's really kind of blurring this thing out quite a bit. So it really depends on what you're looking for, how much blur, how much depth you're kind of going after. And I would suggest taking a look at some photography. Using depth of field can make things that are really large environments actually feel kind of small and things like that. You can highlight certain areas of interest and things. So there's a lot that goes into this. So there's not enough time in this this introduction to really talk about everything that's possible with depth of field and how it's even created. But I just want to show you this kind of simple setup. I'm going to pause this for just a second, and I'm going to pull this down so we can kind of see what's going on inside the world here. I'm going to go to the perspective view, and remember I was telling you if you want to see what's going on in the world with this lighting setup, you might have to go to shading and then use default material for that, and that's going to make it a little bit easier for you to kind of see what's going on here with that. Okay, so we can do this thing where we can go create a locator, and a locator is just, it's kind of like an empty null, but it's got a visual component to it. So if I take this scale, it's pretty small right now. Let me set this to 10 for the locator, and let me pull this out so we can kind of see. Even 10's kind of small. Let's do 100 for it, so it's just really easy for us to see. Now this little thing here is our camera. It's our perspective render camera. If you made your own camera, it's visible, but if it's the default perspective camera, it's hidden, so you have to hit Shift H to unhide that. And remember, we've got display, and you can go to hide or show. So if you want to hide or show items, I'm going to show you this little trick with this thing to where I want this to basically be a distance going out at, like, however we aim this camera, I want a distance going out from that thing. So one thing that we can do is take this locator, and you see it's got its own world position and its scale and rotation. If we middle mouse drag this onto our render camera like this, it becomes a child of that. And what's interesting is if we zero out all these numbers here for translation and rotation, it gives it the same exact location as its parent. Okay, so now we could just push this thing. Sorry, I think I have them both selected. Let's see, let me just make sure I've got that. So we can push this out just in this direction, and if I've got it on the move tool and I've got it set to object, remember if we push in world, it's going to just push along these X, Y, and Z axis. But if we go to object, it's got the object orientation, so we can just push it this direction in Z like this. Okay, so this becomes a visual indicator to say how far out do we need to kind of set our depth of field that you saw in there. So I'm going to use another tool that exists within inside of Maya, and this is just really hard to see that little camera. So I think we can change this to a much larger representation of it, just like that. Now when I did that, I think that is going to set this thing way off there. So yeah, sorry, can't do that. I could have set that before I parented that thing. So hopefully you understand what's going on. Because this is a child of this one, if I scale the parent, the child goes along with it. So if I wanted that visually to be bigger, I would have to do that first. Scale this first and then parent it to it. So I'll just leave that. We'll be able to select it. So we can also create this. We can do a distance measuring tool. So if we go to create and then go to measuring tools, we can do distance tool. And then I'm going to just select on this camera. I'll hold down. I'm going to try to do V and then select this locator here like this. And that should give us a distance for this. Now it's using this first locator like this, and then I believe because I selected this other locator, normally like if you just use the distance tool, it's going to set up one locator for the beginning and the end. We can call this loc start, and we can call this loc end, like that, to keep things to where they make sense. Now I can middle mouse drag this onto the perspective camera for the start for this, and if I took the rotation on this and just zeroed that out and I'm just going to zero everything out. And so we've got this locator, the start, and if we want to see this bigger, we can make this 100 like that. So we've got a start and an end, and then now this locator should follow anything we do with the render camera. This one will as well. I just now have a setup that if I drag this, you can see it's generating a number for me that says what is the distance of this thing. So you can see it's set to 733 units like that. So now I'm going to use a tool that exists inside of Maya where you can connect values of something to another object. So I want to get the value of this distance dimension thing. I'm just going to put this in here too, so it goes along with the camera. And what we're going to go do is go to Windows and then General Editors, and then we're looking for the connection editor. So let's go ahead and load this up. Now this is another topic that's probably going to be just a little bit too much. Sometimes to get to these values, like what I'm looking for is this distance. If I select it and it's already loaded into the left, if I go to look for that distance, I might not find it. Some of these values sit within the shape node. So to get to that stuff, we just go to display and go to shape, and you can see we can open this up. So this is the transform for it, and this is the actual shape node for it. So I know that's probably a little bit confusing as you start off, but if you don't see the information you're looking for, just try to do that. Go to the shape node. So I just loaded the left, and then again what we're looking for is distance, and then I want to tie that to the actual camera that we have. So I'm going to go to the shape node of the camera and reload right. And then what I'm looking for is, if we scroll down, is this AI focus distance. So we can just click that, and now this distance is tied to this AI focus distance. And if I go over here to my camera, you can see that now that there's this this yellowish orange kind of color, and it means that there is some kind of connection that's going on there. So now I can just take this value and I can change it. Let me take this off the shape node, and let's select our camera again, and then take a look. You can see it's going to always be fed that that distance from there. So I think that comes in handy. Now when we look at this from the perspective view, this is really easy for us to move this thing around. If we go to panels, perspective, and look through our render camera, it might be a little bit difficult to get to that, but what you can do, you can see it's only moving on this translate Z, so you can select it and middle mouse drag. You should be able to middle mouse drag left and right those values. If that's not working for you, we could, you could just set this so you could go -800 if you want. If you want to push that back a little bit further, -500, and it'll bring it forward. So you've got a couple different ways of moving that thing. I'll just set it to -800 like that, and then let's pull up the render window here, and then just start to render this. And then again, I've got the aperture on this. Let's select the render camera so we can see the settings for this. This aperture size is set to 5, so that might be pretty big. I'm just going to do a little render region on here because I know this area should be in focus, but this area is the area that is not in focus. So let's just try to get an understanding of what's happening with this. And I probably made that just a little bit too large, so let's just drag this down to try to make it render a bit faster and watch it resolve. So as you get done, you might find, I don't know, maybe I want that even a little bit more blurry than what it is, so I'll pump that up to 8 and see what we get with that. Just let it render and finish out. Okay, so I don't want it too blurry, but just enough to kind of put more of the focus and emphasis on this area. And if you take a look at the locator, we should be right in between these two objects here. So let's drag this over like this and see what we get in this area and what that looks like as that area is resolved. So this should be nice and in focus. And if you are getting really kind of noisy imagery for what is going on with the depth of field, the camera AA is the area to lift up for your samples for that particular area. Okay, so I'm gonna just let that go there because I've already done a render, and I'll show you that again. So here is the final render that I put together, and I did have a pretty high sample rate to get this to be nice and clear for how blurry this is. And this is within focus here. You can see our final image has just a little bit of atmospheric haze on there. We've got the materials set up. So this image has everything that I've kind of been talking to you about. And then this image here, if I zoom in on it just a little bit, has the alternate material type that we took a look at that's got some transparency to it. It's got some subsurface scattering that's going on the object within here. And yeah, so this has got all the bells and whistles and got a pretty good sample rate going. These images do take a little bit of time to render, so I guess that would be my only caution to you, is trying to find the correct sample rate, get the effect that you're going for, and then just expect to spend a little bit of time taking the time to render these things out nice. Okay, the very last thing that I want to talk to you about is within Arnold, you've got this different mode for debug rendering within here, and I'll show you what these look like. And I'll show you how to kick out our images. We can pull that into Photoshop, and if you want to comp things together, this becomes a pretty powerful workflow for you to render stuff in Maya, push it over to Photoshop, and do some compositing of things within here. So if you go to renderer, you can go to debug shading, and then I just did a render of lighting. If you do occlusion, if you just want to get an ambient occlusion pass, you're able to render that out. And we can let that resolve, but you can see kind of what's going on with that. That one's comes in pretty handy. You can do a wireframe if you want to render out wireframes on that. Now I do have the depth of field on the camera, so it is rendering these debug passes with the depth of field on there. So if you don't If you don't want that on for your camera, we could go ahead and click off the enable depth of field, and you can get nice clean renders for that. And then if we go to debug shading, you can get normal information, and you could go into Photoshop and you could take a look at the various channels, the red, green, and blue, and you could use that to your advantage if you wanted to kind of set up fake lighting direction and stuff like that. So there's some interesting things that you could potentially do with that. I'm not going to take a look at UV. I'm sure that it's kind of an odd render. If we go to not the primitive ID, but if we go to object, this can become handy, because if you spit this thing out, you can pull this into Photoshop and you can use this as a magic wand selection, so you can get selections of your objects, so you can turn these into masks. So if you really wanted to quickly tint maybe your cube or each one of these objects, this becomes a powerful tool for you to use within there. The other thing that I do see is that this is pulling in a little bit of information from the environment part. So if you render with these, again, it might make sense for you to go to the environment area, and you could just right click on here and say break connection, and you can see how we can get a nice clean render, and that's going to make it really easy to just select like the background elements and stuff like that. You could always just plug this stuff back in later, but yeah, so that's just a way that you can maybe kick some of these things out. Let me show you how to save these things out. So it wouldn't matter if I was doing the debug shading for the lighting, the occlusion, any one of these. So I'll just say File, and I'll say Save Image, and then I'm going to go to the area that I'm saving my images like this, and then I'll just call this Basic Shapes Render, and then I'll call this Object Mode. Let's go like that. And then depending on what you want to save it as a file type, I wouldn't suggest JPEG. That's got compression on it. PNG, if you want the highest quality and you want to do this conversion work in Photoshop, you can do TIFF like this. Okay, so I'll just save that, or you can use an EXR, but we'll just use a TIFF. I'll save that out. That's the file format that I've been using. And then within Photoshop, let's take a look. I'm going to drag Photoshop down into view here like this. Okay, and it's not playing nice with me. I'll just set it right here like that. So I'm going to go File, and I'm going to open, and I'm going to open that file that we just made like this. Now when we come in, if you save this image as a TIFF file, if you go to mode, image mode, you can see it's in 32-bit, so it's a higher bit. You're going to be limited on what you can do with that, so I'd want to kick that down to 16 bits at that point, and you can tell it to just merge. And then you can see the colors are going to change quite a bit if you just let it use this local adaptation. So there's all kinds of sliders. You can play around with this to see what you get, but I just want this to be as close as I possibly can get to the original image. I can turn the preview off for this, so if I just use this exposure and gamma, this is the one that I found that gives you the best results from converting it over to not really change too much at that point. Now I could take this old render of mine. They are a little bit different as far as sizes, but I'll just do this for demonstration purposes. So I'm going to hold down Shift and then drag it into here. I'm going to hit Control T to scale this, and I'm going to scale this up here into the corner like this. This is definitely not the best way to do this, but you can see got the scale. I'll just set enter for this, and then I could just maybe do an overlay of color information on this and just kind of gently slide it back or whatever. So again, I was telling you could use this as information for selection on there, so you could definitely do that. You could do things like this where I set this to color. Now we've got the possibility to go through with some different blending modes and check out what that gives us. But like what I was saying is if we put this on normal, and I'll just put this at opacity of 100%, and if let's just say I wanted to select the background, I'll tap W for the magic wand tool, and I could put this at a really low threshold for the tolerance for this, and then if I did this, took off this contiguous, I can select on there, and it should be able to select once, and it should select the inner part as well. It looks like it's getting some kind of a haze on there. So let's go back to 32 and select something like that. If I hide this, now I could go and maybe, I like to use these solid color layers. So if I go to click on solid color layer, I could select, let's just say I make it a bluish background or something like that. And maybe I choose a blending mode of overlay for that, and then drop down the opacity. And let's say I don't like that blue, I could double click on it and push it to a different color. That's the thing I really like about these solid color layers, is it's possible for us to go through afterwards and reselect things and change values and stuff like that. So I don't really want you to do this to your background. I just wanted to show you this as a possibility. And then also, even if this is hidden, if I just put on the magic wand tool, this is hidden as a layer, but if I select it on the layer, then it becomes possible for me to make that into a selection, and then I could go solid color for this, and I could change the color information. Maybe I just put this to a blending mode of just color like this, and I can kind of ghost this back. Now I am getting some fringe on the edge and everything. I did something not so great. I basically did a smaller render and scaled it up, so should be rendering these all at the same size, and that's going to give you better results and everything. But I just wanted to kind of quickly show you how you could do some renders and pull that over and pull that into Photoshop. So now I think you've got a pretty good base foundation for maybe an understanding of how you can build some cool shapes inside of Maya. You can push these into Arnold. You can do some really high quality rendering. And then if you want to get into it and doing some comping inside of Photoshop, that becomes a new possibility for you as well. So you've got a lot of new tools at your disposal to start creating some compelling imagery.